Hello and welcome back to Compiler Programming. With the Hello World milestone out of the way for parsing, I think it is time to do a little bit of refactoring. And in particular, I don't really like that we have this repeating setup for the program. So this is what I will start with. I guess we will put it somewhere over here where we will just program free. Sounds good. So we can say like void program make, and for now maybe it will not even take any arguments, and it will return us a program. Okay, and we're just gonna grab this stuff over here and do something with that. Okay, so instead of allocating it on stack, we will allocate it on the heap, and we'll call this destroy, and we'll expect to get the program itself. I think we also need to add allocator to the program, although since we're using temp allocator for everything else, I'm just gonna not care about that. And then this is gonna be also like this. Yeah, I think that's fine. We can also do it more C-way, which might be actually a bit nicer here, because then we can do it on a heap and a stack. So we say program init, and we get a pointer to the program, and we just say program is this stuff, program, yeah, something like this. We don't need this, and we return the pointer that was passed to us just for convenience. And then this will be the init. We don't want to free the program actually. Also free is wrong anyway. Scope make, it doesn't know what that is. That's fine. Right now we don't have source headers. We might have to do that. So okay, well, let's make that happen. I will just copy value headers and get source one in. So let me grab this here. It's gonna be source h. It will include value h. We'll get rid of all of this stuff. This will be source h, and I want to have scope make defined there, because we will need that. And here, just for consistency, I would say source.h. Okay, that looks good. The only thing is we need to define the scope. I think right now I shoved it into value actually. No, here is just a forward declaration, but we can remove that, and instead we can put in the real thing in the header here. So that's better. Obviously that creates a bunch of issues, but nothing that we cannot fix. So now this guy doesn't know what is the global scope. That's okay. We will well, actually we do need to keep this forward declaration, but that's okay. Drag this over here, And let's see what we need to do. Scope make is unknown here. That is easy to fix. We just include scope.h, scope source. Okay. And test program. Instead, it will be program. That is good. Let's see where else we have issues. So here, he doesn't know what the hell is array token pointer. That's because all of that is defined here, but we can probably grab all of this stuff and yeah, and move it to the header. Okay. Now I just need to also say that scope define value is a thing that we will need. And reference in function program init. So okay. Now we have this spec and we just need to include source in it. Okay, that's good. And test program functions. This is not interesting, and this is not interesting. Instead, we'll say program dinit, and we'll say program underscore. And for the rest, we'll just say program here I can actually do it like this. Program, and then I don't need the other one. So I can do program init of this. We don't need this stuff anymore. This becomes much nicer. Let's see if that builds. Initializer is not constant. Okay. So I do need this. Can I? No, it cannot be constant. I think I might be able to do something like that. Okay, that seems to work. Let's try to run the tests. And all the tests seem to pass, which is great. Before I commit this change, I want to propagate this stuff into other places. I believe we have similar setup in this file. And this is one of the reasons I'm actually doing this change, because it's not great that we have very similar setup in a bunch of places. So this needs to go. This is now the init, and this is 0, and this is test program. Let's try to run these tests now. Okay, that's good. I think final place where this is necessary is inside of where is this? It's called mass. Let's see. Yeah, here where we are dealing with the CLI, we should do like this. Yeah. I can do program init like this. Okay, that is very nice. Build, and I can do build slash mass fixtures exit code mass. Okay, that seemed to have produced something, so that's great. Cool. I will commit this part. Factor out program initialization and initialization. Good. That's very, very nice. The next topic is going to be a bit more complicated and involved. And the actual refactoring will take a while, but I will only do the preparation work on the stream and then go through all the functions and actually make that happen off screen. And the idea is that it would be nice to not have this boilerplate be present, and additionally somehow make it so that we test both programs, like for every test program that we have, we should test it from as a JIT and as a executable. And right now this is sort of some tests do one, other tests do other, and it's not very very scalable, let's put it that way. And maybe we'll still have to do some boilerplate stuff to figure out how to test both. But for now, I just want to have some kind of scaffolding that would allow to read the program, compile it in two different ways, and then run. And I think the way I'm gonna do that is actually take this code and extract part of it. How do I want to handle this? So I want to have a function that basically accepts a file name, or maybe accepts a buffer. Well, technically we already have a function that accepts a buffer, so that's not really something interesting. But let's start like this. Let's start with being able to run something from command line. So right now we are just compiling, and this is because we are doing this stuff here, right, where we do write executable. So what if we add a command line switch that allows to say run? And here we say that if it is less than 2, then we print usage. And I can say, like, you can say minus minus run, and we will add an enum, say typedef enum mass CLI mode, mode compile, and mode run. We start with the mode being mode compile, and then what we will do is loop through the argv. So u64i is 0, actually 1, is less than argc plus plus I, and now we need to do the checking. So if I actually have no idea what is the name for Weicher Aster CMP. I think it's called something different. It's called VCSMP. Okay, so that's what we need to use. So if VCSMP CSC, yeah, okay, of argv I is has, or let's put it that way, file path is 0. If it is 0, and second one is going to be L minus run, else if file path, then I will create a helper method, say void mass CLI print usage, because I will need to, and this actually should return S32, and then we can do like return -1, and I can do here return like this, and if file pass, then return usage. So basically I disallow to have more than one file passed here. Otherwise file path is argv I, something like that. And if they are the same, then we say that mode is mode run. Okay. For the run mode, it's very interesting. Later on would be how to deal with syscalls. So like I'm using exit process directly as a part of this run, and maybe what I should be doing is like launching a sub process for this instead of running it in the current one, but that's okay for now. I can figure it out later. So this is good. Let's see if that builds. Signed unsigned mismatch. That's because this is 32. Okay, and now the cool part, where I say that well, entry point is fine, and here I say if mode, or better yet, switch of mode, case mass CLI mode compile. We do one thing. If it's not gonna be compile, we will do another thing. Okay, something like that. So this compile, we just write out the executable, and we can add to do generate correct file name. And if it is run, then what I do is pretty straightforward. I will look up here and say that we have this value as a function, and we expect it to be void to void, and this is gonna be basically like that. Except it's not full, it's program entry point. Okay, that looks pretty nice. Let's see, test actually won't do anything, but now I can do build slash mass, and it should show new usage that has this run. And I can do build mass minus minus run fixtures exit code mass. Okay, that did not work at all, and that is because I forgot to say program end. Like this. Okay. Well, let's try that again. And if I do echo error level, we actually have the correct thing. So that's great. And I'm not sure if I want to do it from the CLI or from C, but the idea would be that we just iterate over all the fixtures, and we do it in both ways, and then we just compare the output and hope it is a correct one. So I will have to set up all of that, but just as one final thing I want to do is to create another fixture so that hello world that we had yesterday, I can now make it happen as a separate file, and not just separate file, but something that we can pretty easily run. So I don't need to convert this. This is gonna be 0. Get std handle. So I'm just gonna copy it like this, and hopefully I will not do the same mistake as I did yesterday with forgetting to change the some of the stuff here. So that's like this, and I just need to, well, here's a handle. I take this stuff, put it here, and get all the quotes correctly. And I think that's it. I'll need to definitely change the build script to also maybe run tests or something. I don't know. Let's see how you want to set it up with the editor so it's easy to test this. But for now, what I want to check is fixtures hello world. Okay, so it worked, but it actually crashed afterwards. And I wonder why it crashed. So if I run tests and I run build parsed hello world, that actually works just fine. But the run one seems to crash. Well, let's try to debug that. And environment solution. Sure. I'm on Visual Studio. I believe that you can open a project that contains one file and prepare the solution for it. Okay. This is a mess. Here, fixtures. Hello world. And minus run. Okay, and this is what we are trying to test. Access violation, reading location. That is unfortunate. Okay, the way I need to do that, I guess, is to break here and then go to disassembly, go to here, jump in here and start trying to understand what needs to happen. So this is getting the std handle. Then we are saving the result and we are loading the address of the next function. And then we are preparing all the arguments in a very inefficient way, but that's fine. And then we are trying to call write file. So write file is done. Then we do this. Just rechecking that I have correct names everywhere. So I mean, this seems fine. What if I do Rax? So this is what Rax contains. What if I say exit process? Identifier exit process and event. Is it undefined everywhere? Maybe I should try to add it to the source code so we can compare that address is correct. So it seems to fail when we try to call exit process. I wonder why that is, if the other function is... Okay, what if I remove this and keep the imports? Are you happy with this version? So this version is fine. It is calling exit process after calling write file that somehow is messed up. And I'm not even sure what the issue is there. But one thing I do want to do is here to have exit process of 0, just so that I can look up if the address is correct. Okay, F5. Okay, so this is the address of this is very, how do I copy value, I guess the right thing to do. Okay, so this is what we want to see in racks, and let's see if we actually get that. Wait. So something is not right, I think. Okay, so this Leah is the string. Okay, so that's fine. And we exploded. Whoa. Yeah, actually this address will totally be different. How do I debug you, considering that this is just pure assembly? Not sure. Let's go inside. So this is first call. Where's the second call? So result is 1, and that means it was successful. So everything is fine here. It is it really looks like the address is incorrect and we are jumping somewhere to not the right place. What if I do F11 here? Yeah. So we can't even jump to that location. Like, this looks like a very strange address. Before I go and look at how we are loading those, what I want to check is here, how are the other addresses looking like? So this seems like a reasonable address. Yeah, we have 4 zeros at the front and then stuff there. Let's see how write file looks like. Write file. Damn it, I missed the right address. But I think it is this one that is wrong. And it looks like it is shifted somehow by 4. So if I do 0x like this, and I treat it as a void star, and I say star, I treat it as 64 unsigned long. Yep. So we have 38, then we have 40, and that seems reasonable. And then we have 2EH. And the reason we have 2EH is that 20 we have, oh yeah, this is really screwed up. So I'm trying to do, there are multiple problems here. I'm doing an unaligned read from the memory, and that is not good at all. The problem is when we are doing this copying of the string, we need to make sure that we correctly align that. Where is that function? Global string from slice. Yes, here. And actually it is this one that needs to do the right thing. Array value pointer. Wait. Yeah, we have value address. So we allocate bytes. Yeah. Here we actually need to do correct alignment. So this last argument is alignment, and alignment needs to be the do I have a function to check the alignment of stuff? So we have descriptor byte size, and do we have alignment? Yeah, that's actually not really correct, because for arrays, alignment will be screwed up. Okay, so what I can do is say descriptor alignment, and it returns, well, I guess it returns, what does it return? Descriptor byte size returns U32. Okay, I can return U32 as well. It gets a descriptor, and if descriptor type is descriptor type fixed size array, then the alignment of that is the alignment of item. So I need to say that return descriptor alignment of descriptor array item. Otherwise, we do descriptor byte size of descriptor. And here instruct, we actually should do field alignment instead of byte size, and but the row size here we actually do need to say descriptor byte size of field descriptor. Actually, U32 field size with alignment is max of field alignment and this. Something like that. And now I also need to take this and use it in an original thing where I say U32 alignment is descriptor alignment of descriptor. And here it needs to be like that. Okay. Now I can try to look at if we get a better address out of all of this. Go into here. That's fine. Fine. And we do not. That's weird. Like 2E is just the wrong thing. Oh, that's because let me think about that. So E, if I go to hex, E is 14. Yeah, that's hello world with 0 byte. That is very, very strange. Okay. Our problem is when we get to exit process, we have the wrong thing. I guess let's try to see what's going on with that value global. In here. Okay. F5. It might be that when we are importing, we are not doing that. Where is that thing? It is in program and okay, it's not here. I guess it will be inside of the function. Yep. So it tries to allocate things here, but this should align it correctly. Unless I'm misjudging stuff. So let's do it in both places. You're also going to function and go with program end and see what's happening here. let's start again. Okay, this is the global. This would be our string if I understand correctly. Descriptor type is fixed array, and its e of size, its alignment is 1. Okay, that is fine. And fine. Okay. Here it's should be everything okay. The only thing I want to check. Actually, no, at this point everything is fine. We can continue. I guess this is where we would have an issue. So we have this kernel 32 DLL, and we get the first symbol, we get a string, we get proc address, yeah, so this is the bug. I cannot do this. Instead, I need to do what I'm doing in here, which is where was it? Global. Yeah, offset and data section is this stuff. And I differs in level of indirection. Yeah. So I need to cast this to S8 star. Something like that. Let's see if that helps. 5. I don't need this anymore. This was actually correct. Or now it is correct. And I will remove this one for now. And go into here. Actually not in there. Go in there. And it looks like we actually exited with successful status code. So I'll just run this. Okay, yeah, now everything is great. This was the error, and all in all, this wasn't at all what I was planning to do, but I think that's a very important thing that we fixed, and it is very nice that it was caught with a relatively simple example rather than something very complicated. I guess that would be it for today. Now that I have ability to run things and compile things, as said, I will just try to reorganize the test slightly to take advantage of that. And then in the next episode, we can continue working on some nice new features. Thank you very much for watching, and hopefully see you then.